Good morning, everyone. Hello, and a very warm welcome to the first FORTIS webinar, The Future of Human-Robot Interaction in Europe, Trends and Policy. My name is Daniela Fonseca. I am a project manager at F6S. I will be your host for this session, and with me I have Anne Florence. She is a communication manager at F6S. We have an incredible program lined up for you, and we will have some of the pioneer voices in robotics and technologies. Before we dive into our exciting webinar, I would like to quickly go over the agenda for today. The webinar will run for 1 hour and a half with presentations from three European projects, and a presentation from a policy officer, Cem Gulek, followed by a roundtable session. I would like to introduce you our STEAM moderator for today's session, which is Leila Bastida. She's not only the moderator for today, but she's also the coordinator of the FORTIS project. She received a PhD degree in science computing from the Usto University in 2008. And she also has a master's degree in gamification and transmedia narrative. She's currently the head of the Advanced Interaction Platform of Technology, and she has extensive experience in research projects, having coordinated and collaborated on several articles and several projects, both at international and national projects. Her research interests include themes of human factors, robotics, and also user experience, person-centered design, gamification, among others. As the project coordinator of the project FORTIS, she's perfectly positioned to guide us through today's topic. And without further ado, dear lady, it's a pleasure to have you kicking off this webinar series as our moderator, and the floor is yours.
Okay, thank you very much, Daniela. It's a pleasure to be here and to moderate this webinar. I am going to share my screen first. Okay. Can you see the screen right? Okay, that's great.
Yes.
So thank you very much. It's a pleasure to be here. So I am going to start presenting you for this project. For this project is a European funded project that is focused on enabling robots to interact with people in a human-like way over long periods. So during this presentation, I will cover what FORTIS is, which are the technologies we are building here, which are the expected outcomes, and how we are going to put our developments in 3 pilots across construction, infrastructure, service, and manufacturing. So let's start there. Okay, let's start with what FORTIS actually is and why it matters. So FORTIS aims to provide a human-robot interaction solution. That is, this interaction is performed over long periods. So the objectives are or include human-centric modeling analysis, flexible multi-robot interaction, and also safe and trustworthy human-robot interaction, where we want to optimize the different operations that both human and robot collaborate in. So as I had mentioned, here we have we are tackling 3 objectives. The first one is human-centric understanding, where we are modeling and analyzing which is the human status and the context. So robots can interpret the intent of the human and adapt to those intentions and also to the human state, for example, as fatigue or stress. We also have the robot-centric agility, where we want to provide multi-robot systems that are intelligible, reconfigurable, and also responsive around the persons. And also we have the third pillar is the trustworthy and safe human-robot interactions, where we integrate safety, digital twins, and optimization, so the operations are both efficient and reliable. So with these 3 pillars in mind, the human, the robot, and the trust, we will frame the rest of this talk. Okay. So the outcome of FORTIS is focused on three main toolkits. We call toolkits, and as you can see, are the same objectives I have described before. First, we have the human-centered toolkits that you can see here, where we are covering aspects as human-centric data collection and annotation, analysis of human behavioral cognition and activities perception, also which is the information exchange between the human and the robot in the context they are working on, and also to adapt the communication through different multimodalities to the human robot. The part of the robot is focused on, of course, on the robotic solutions, also including IoT hardware and IoT software to collect more information from the context through sensors and wearables. And also here we have what I have already explained, all the behavioral intelligibility and adaptation and the dynamic and reconfigurable multi-robotic systems. Finally, the last layer is cross the human and the robot part. It's about working with digital twins, having a watchdog to focus on human safe and privacy, and also the optimization of resource allocation through an agile methodology. So, which are the three pilots we are working here? So we are working on construction sector, we are working on the infrastructure service and the manufacturing. In the construction sector, we are working on buildings through the techniques of sandwich panels. In the infrastructure service, we are working on railway maintenance. And also in the manufacturing, we are working on the productions of consumer goods inside an assembly line. Before proceeding to explain these use cases, I would like to detail or remark which are the different human-robot interactions we have identified in these different pilots. So we have these three sectors: construction, infrastructure, service, and manufacturing, and we have identified different use cases for each of them. So for example, in the case of construction, that is focused on the assembly of the sandwich panel to construct the buildings and the material transportation. The communication mode, for example, in the assembly would be verbal and haptic. So here we have a combination of physical and non-physical interaction. And in the part of material transportation will be visual communication mode. So here is more focused on the non-physical interaction. In the case of the infrastructure service, where we have two use cases, one focusing the maintenance of the features of the railways and also in the maintenance of the railways, in both of them, we use the communication modes as verbal and visual, okay? And finally, in the manufacturing use case, it's more focused on smart AGV splits with collaborative cargo robots. We include not only verbal and vocal, but also haptic interaction mode. So I would like to provide you more details about the pilots, and we have included here some videos because it provides more visual explanation about what we are targeting here. So as you know, construction is a sector that has some difficulties in integrating these industrialization techniques. There is a low integration of technology. And that is one of the challenges we want to address, because the interaction with the human is very, very relevant here. So in the use case one, that is the sandwich panel assembly, you can see in the right side, the video about how they are assembling the panel. The goal is to equip a telehandler with the FORTIS solution, some way to automate this telehandler. So we can reduce the team down to 2 workers, only 1 worker on the ground and another on the elevated worker. And they can interact with the telehandler through gestures to let the robot to know how to approach the sandwich panel in order to assembly in the build. The second one, as you can see here in the low video, is about the transportation of construction material. So the goal here is to equip a bobcat in order to, so this bobcat is able to, in an independent way, to locate and move material across the construction site. So the bobcat is able to guide itself, to navigate, but at the same time, you need to avoid accident with humans by adapting this motion. So this part, the visual part is very, very important here. I would like to remark that this first pilot is provided by Garcia and Garcia Constructions, a Portuguese company. The second pilot is provided by VIAS, a Spanish company that is focused on infrastructure service. And here, one of the main challenges or the main characteristics of this sector is the need of speed, safety, and accuracy on the process they are doing. So the first use case is just to maintenance of the track features. So the goal is to equip a robot that will sit on the tracks, and this robot will detect faults and help change click automatically with the help of the human. And it will provide the human information about how much pressure should be done to apply these clips. The second one is just the maintenance of rails, because in the tracks, normally with the use, you can find rail anomalies, and you have to perform grinding in the rails to solve these anomalies. So the idea is also to equip a robot that will also go on the tracks to detect these rail anomalies. And while the person is doing the grinding process, will evaluate if the grinding is done well, or the human needs or the worker needs to do it again. So we'll provide this feedback to the operator to ensure that the grinding process is well done. And finally, the third pilot is provided by Beko Arçelik, a company in Turkey that they are focused on consumer goods assembly. And this manufacturing sector is the main challenge here is that they need to have a lot of AGVs moving in the factory. So they need some efficient and safe logistics of the product movement inside the factory. So here we have finally identified two use cases. The first one is about the human-robot interaction in order to guide these AGVs. Because the AGVs normally they follow fixed packs on the floor. So the idea is that they can read or communicate through gestures with the nearby workers. So the workers can instruct the AGVs how to surmount these problems, because it can happen they can find an obstacle, and then the AGV doesn't know how to proceed. So with the help of a worker that guide the AGV can avoid that obstacle and continue the working on the factory. The second use case is about human AI interaction for leveling the supermarket order activities. So they have different workstations, and they have what they call a supermarket, where they collect all the material they need to be used in the different workstations. So the goal in this use case is just to focus on the optimization of resources. And by doing that, we want to automate the ordering process. So the worker, through natural interactions, can order an AGV to collect different material they need from the supermarket for the next activities they are going to perform. Here, one important challenge is that the timing is very critical, not only to reduce the traffic jams, but also to keep the efficiency and productivity in the different workstations. And that should be all. This is a general overview of FORTIS. We are in our second year. We are working on the development of all these solutions in order to start the deployment and the validation in the pilot phase. So we don't have demos at this stage. So I hope in our next webinar, we can show you something more tangible about the developments we are doing in FORTIS. So here you have all our social networks and also my email in case you need to contact me. Okay, so that should be all from my side. I think now we can have some questions. I don't know if there is some questions from the audience.
Yes, dear Leda, there is a question for you.
Okay.
That is, how does the FORTIS project contribute to the European priorities like digital resilience and security? Because I'm not sure how people see this, but since there are 3 different pilots, maybe they are asking in general
Yeah.
about
Okay.
the digital resilience and security.
Yeah. Okay. Regarding security and safety, we have 2 different areas. So regarding safety, because we are using robots, we also need to be compliant with the different safety requirements and security requirements at European level, also regulations. So we are ensuring that all the robotics we are developing here are compliant with them, with those regulations and standards. Also, as I have mentioned, we have one part critical in the project is what we call the watchdog. The watchdog is what is providing some kind of overview about how we ensure the security and safety in all the developments we are doing in FORTIS. Okay, so all this part, we are starting to work on it. And the idea is to analyze all the solutions, all different toolkits I had mentioned, the human, the robotic, and the trustworthy part, so they can have their specific watchdog to provide us guidelines about how to ensure that we are compliant with different safety and security regulations and how we need to implement them to improve our solutions. So we are more closer to real deployments in real sites instead of focusing only on validation or demonstration in lab control environments.
That is great to hear, dear Larry, and having this idea that the pilots actually aim to get results closer to what happens in real life
Exactly.
gives a different idea and a more robust idea of how projects like this contribute to digital resilience and to a stronger and more digital sovereignty. That is also good. Dear Larry, before you move to the presentation of the next speaker, I wanted just to remind you that the next speaker will be Cem Gulek. Conscious of time, he will need to jump in before Zoya Arculi. So feel free, go ahead.
Thank you very much for the reminder. So I am going to start to share. So now we are going to go with Cem Gulek, Program and Policy Officer that is working on the area of artificial intelligence and robotics. So please, Cem, you can share your screen so we can start. Thank you.
Thank you very much, and thank you for organizing this event. We are always happy in the EC to see that this kind of event is organized, especially when it brings several projects together and when they are collaborating. Just to introduce myself, I'm Cem Gulek. I'm working in the AI office in the unit that is called Excellence in AI and Robotics. In that unit, I am involved in policy matters, but also in projects, mostly focusing on robotics, but not only. I'm also in charge of the relation with ADRA. Today, however, my presentation will, even if I'm working more on robotics-related matters, I'm not going to focus on robotics only. I will provide you a global picture of what we are doing in my unit. I would like to start with that slide that is showing the ecosystem, the classical ecosystem drawing that we have in our units. As you see, we're active from the lab to the market. This makes a circle from a research and innovation project till the ADs. In collaboration with ADRA. If we start with ADRA, ADRA is the private side of our partnership in AI data and robotics. We are working with them to define funding priorities, and then we implement research and innovation project as your project. We select proposal, and then we have running project, etc. We also have specific group of projects like the Network of Excellence Centers, each one focusing on specific area. The AI on demand platform, which is the place where we have the developers, but also the users of AI solutions. This is a place also where we ask project to share results and to make use of. And now in the left side of the slide, you have what is in pink. You have what is funded under Digital Europe program. We have the testing and experimentation facilities. So higher TRL, where we test solutions. We make the final test in almost real environment or real environments. And then the AD, which is helping companies, especially startup and SMEs, to bring AI solution into the market. And we have been investing a lot over the past years in this, and we have very ambitious targets, as you can see, on digitalization of our companies in Europe. But this was the classical ecosystem presentation, but you have heard and you have seen earlier this year, we have also initiatives and action plans that have been announced recently, especially that one, the AI Continent Action Plan, announced in April this year, where we want to make Europe an AI continent. So we want to compete against global leaders and to be there. And for that, we have 5 pillars: data, skills, so the development of algorithms and adoption of algorithms by the user of solutions, regulatory simplification, and compute infrastructure. I will go one by one into the 5 pillars and explain what it is very quickly. So if we take the computing infrastructure, you know that we have several AI factories in Europe already, and we're expanding them. And those AI factories are being also upgraded so that they are more fit for AI, and so that user of these computers can make AI user of this solution can fully develop solution using these computers. We also have the Cloud and AI Development Act and the Gigafactories. So in addition of the AI factories that have been announced earlier this year, we have huge amount of investments, 20 billion only for the Gigafactories. That is will be launched soon. So we are still in the preparation phase of that. And now this slide is to present you about the Apply AI strategy, which is more the focus of what we are doing in my unit. Indeed, the previous slide on the factories and gigafactories is the focus of other units of the European Commission, but it is linked to AI. In my unit, together with other unit coordinating AI in the AI office, we contributed for the development of the Apply AI strategy, which is about bringing those AI data and robotics solution to the users to facilitate the deployment of the solutions in industrial sectors, in public sectors, but also in science. This slide is to show you the different steps that have been performed to design this Apply AI strategy. So we contacted industry, civil society, academia, RTO, citizens, and member states to contribute to it. And we are now at the stage where the finalization of this Apply AI strategy that will be announced in a few weeks. Those are some of the sectors that are considered for the Apply AI strategy. It is based on the sectors already identified in the Draghi report. You have advanced manufacturing, mobility and automotive, pharma, agri-food, energy, but also robotics. Robotics is an important component of this Apply AI strategy. As you can see below, we also have public sector and science that are considered under this strategy. But if we get back into the past, the Apply strategy to be announced very soon is not coming from anywhere. It's also linked to the GenAI for EU initiatives, which was an initiative announced with the AI Innovation Package January 2024. So it is linked to it. So we have some differences between the two, but it is linked to it and it is building on it. And just as a reminder, the GenAI for EU initiatives more specifically about generative AI. So Apply AI is not specifically only about Gen AI, but it includes it, and about bringing it into the sectors that you can see on the screen. And you can notice that many of those sectors are identical to the one of the Apply AI strategy. So for this Gen AI for You initiatives, we have been co-creating initiatives and calls, Horizon calls, and we already have 690 million planned calls, so that are already committed. We announced 500 million for that initiative, and you can see that we are already surpassing this initial commitment. And this is the slide I would like to finish with. If you remember the first slide, we were about the innovation and research and innovation ecosystem, but I would like you to also have a look on that slide, because we can see here that we are expanding it now, because we have ADRA still, this is our partner, the private side of our partnership, but we also have infrastructures like the AI factories. We are increasing the role of the TEF, the testing and instrumentation facilities, to further develop solutions and to facilitate the uptake of solution by the users. We also have AI endowment platform as a priority, but we also have AI regulatory sandboxes. And again, as for the TEF, we are reinforcing the role of the ADs to facilitate the uptake of the AI data and robotics solution by companies, especially startups and SMEs. In the middle, you can see that we have the AI office that has been set last year, and now we are fully, there is no transition mode anymore. We are fully operational. We have the AI board. That is the board where we coordinate and collaborate with the member states. And I wanted also to see, you see on the left side, we have the ecosystem of trust with the AI Act that was adopted, and we are implementing it pieces by pieces. It's not implemented all in once. Our colleague, it's not my unit, are heavily working on that, and we have many requirements of the AI Act that are implemented right now. As you can see in that slide, we try to find a right balance between regulation, the left side, and research and innovation. And this is the combination of these two that will make Europe an AI continent, a place where we are leading in AI. I think it was the last slide. Thank you for your attention. It was the last slide of my presentation. In case you have questions, I am here to answer. I cannot stay long, but I can take some questions if you have.
Okay, thank you very much, Sam. So I think we have two questions in the chat. So the first one say that statistics indicate that by 2030, 75% of European companies have taken up artificial intelligence. So are these mainly manufacturing companies, or what does it take into account this number?
I believe it is about the first slide I showed. It was 75% of European companies have taken up the AI. Is the objective of the digital decades. So it is the target. Okay. It is the target. Sorry, I was not precise when presenting the slide. This is what we want to achieve. And this is why we are making so much efforts to bring these technologies into the market, and especially into SMEs, because usually it's more complicated for them.
Okay, thank you. And we have a second question. What are the main challenges in policy for artificial intelligence and human-robot interaction? For robotics in general, what I can say, the challenge that we have been identifying with the community, so we have been contacting also ADRA and Robotics and others, is we have many challenges to bring the solution into the market. First, the end users are not specifically always very familiar with those technologies, and we need someone to explain them and to guide them
to adopt solutions, because you have the supply part of those technology, they know very well, but the demand side is not always fully aware about the possibilities that the supply chain can offer. And we have a need of bringing here actors, maybe integrators. Sometimes in ADRA they call it super integrators, that would link the supply side with the demand side. Especially again for SMEs. SMEs are small companies that do not have maybe engineering department or AI department to help them taking those technology on board. And those type of actors would facilitate the uptake of ADR solutions. This is one of the challenge, one of the possible solution. But what we also plan to do in the EC is also to take from the demand side also some specific use cases, and to have a fast research and innovation funnel to bring the solution into the market. So to make effort and not to stop, to facilitate the uptake. So to go from low TRL until the very high TRL in a quick manner, so that we are not slow also in our in the uptake of the technology, which happens in other region of the world. They're very quick, and we want to be very quick as well.
Thank you very much, then. So I think that we can close this part and we can proceed with the next presentation. So thank you. I think you need to leave. So thank you very much for attending today.
Thank you.
It has been a pleasure.
Bye-bye.
Okay, so now let's continue to present the JARVIS speaker. So Sawyer Cooley is a mechanical engineer that is specialized in intelligent cooperating robotics for manufacturing. She's coordinating the European funded JARVIS project, and is focused on the human-centered design of artificial intelligence power systems for agile productions. So the expertise of SOI includes human-robot collaboration, of course, reconfigurable workstations, and also the ethical adoption of emerging technologies in industry. So SOI, please, we can see your screen, so you can proceed.
Thank you for the introduction. Thank you for the invitation to the event. It's really nice to have the sister projects together to see how we are both pushing and advancing human-robot collaboration. I would also like to welcome the participants and thank them for being here. So indeed, my name is Sawyer Cooley. I come from the Laboratory for Manufacturing Systems and Automation, LMS for short, which is a laboratory at the University of Patras in Greece. LMS is the coordinator of the JARVIS project, and actually I have the pleasure to run it. So today I will introduce roughly how all the project runs. So this means that we will discuss our consortium, who we are, our vision and motivation, use cases, because what distincts JARVIS is the industrial-driven methodology that we have. So it's mainly the end users that guide us. And then we will focus also on expected impact and our open calls. So in brief, the project is funded by European Commission under the Horizon Europe program. It started in January 2024, like FORTIS, I guess, and will run for 4 years. As you see in the full title of the project, we are about intersubjective AI-driven multimodal interaction for advanced user-centric human-robot collaborative applications. So what is special and probably is not often seen is the intersubjective term. This means that we want AI and that understands the shared context with humans, and this is what we call intersubjectivity. So we combine multiple modes of interaction, such as vision, gestures, speech, and haptics. To enable humans to interact more easily with the robots, the goal is to create a collaboration that it's not only technically advanced, but also user-centric, and at the same time safe and trustworthy, supporting real adoption across the industry, which is currently a bit lagging. So to achieve this, we are committed to advance human-robot collaboration across 4 industrial use cases in the sectors that we will see in the next slides. Here you see the team of JARVIS. We bring together 16 partners from 11 European countries. We have leading research institutions, which are joined by industrial players such as KUKA, for instance, and major associations like SESIMO, which are working together with our end users, EDF, Equinor, TOFAS, and Collins. Now about the motivation. We believe that even though there is intensive research in Europe, the wider industrial adoption is still lagging for human-robot collaboration solutions. And we think that some of the main reasons behind that are the limited cognition and intelligence of the robots. So even though we have some solutions, we could say they work isolated for specific parts of the process, and the robot should still be enhanced in terms of cognition. In addition, the collaborative operations often show low performance. This is because of the stops during the safety systems, due to the safety systems, but also because sometimes we see automation failures for different reasons. Programming is still complex, so we still need experts to program, reprogram, and adapt robotic processes. And finally, the interaction between humans and robots lacks fluidity, in the sense that we mainly see in production lines the human waiting for the robot to finish some processes before they do something. They are mainly the supervisors, and we don't have the robot adjusting the rhythm to the operator. So this might reduce acceptance and overall the experience of the operator. So the vision of JARVIS is to overcome these barriers. This is through a set of reusable set of tools, which are mainly based on AI and multimodal interaction. We want to create intuitive interfaces for both physical and remote information exchange, but also robot control and programming. We want to enhance robots by providing them with social skills for easier, more natural interaction that also feels safe and trustworthy. And of course, we want to demonstrate that these tools can work scalably across different industries and economies. So JARVIS, we can say that is in a nutshell to advance cognitive, trustworthy, and socially interactive robots, while keeping the human at the center of the collaboration. In this scheme, we can see the modules of JARVIS, the building blocks. It's a generic framework, we could say, where everything is visible. At the core, we bring together technologies that make collaboration between humans and robots safe, natural, and flexible. So this starts by AI-based perception to understand human actions and the environment. This is enhanced with human intention prediction and human action recognition to ensure that robots anticipate and adapt to operator needs. Of course, you see our HMIs that are enhanced by advanced interfaces like AR to have overlays of information directly in the workplace, but also VR if we want some remote control. And these building blocks are then implemented in our 4 large-scale pilots. These pilots are structured in 2 pillars. One is about agile manufacturing. So the first case is from this pillar. We're working with Collins on this aeronautics case. In particular, we have here close human-robot collaboration for the production of composite parts and specifically the seats. So the current state includes repetitive and ergonomically challenging tasks. We have like co-manipulation, as you see here, of flexible parts, and this is stressful. Sometimes we have wrinkles which introduce the need for rework. We have scrap, waste of material. So here we add robots to support humans with the placement of materials, to be precise. There are also some systems to support the human who remains at the center of decision making. This tool supports with AI detection of defects. So here, I guess you have a sense of how this case aims to promote safer and more productive collaboration. In the same spirit, we see again close human-robot collaboration in the TOFAS use case. Here we are in the automotive industry, in the assembly of hybrid vehicle battery packs. Here there's a lot of screwing, there are cables, connectors, clamps that need to be assembled. So all of these tires human. There are ergonomics risks. There is the handling of heavy parts. So we add here the robot to support human physically. There are some assistants to support human with memory gaps, like what should we do next? So here we have multimodal interaction, intention prediction, and AI-assisted one support with what to do next, but also programming for the new parts. And the scope is to have a reconfigurable, scalable, and operator-friendly workstation. The third pilot moves into a completely different domain. Here we have inspection and maintenance activities. It's the second pillar. And we're working with EDF for the nuclear power plant's decommissioning. The current state of the nuclear plant decommissioning involves highly hazardous environments. As you understand, operators face significant risks due to radiation exposure, confined spaces, and complexity of dismantling operations. So the vision here is to introduce collaborative robots with immersive teleoperation. So the humans are away from the robots in a safe room, and they are working with the robot to support these dismantling operations that are needed. Here we have AI-based perception to support the teleoperation activity, and there's VR to enable the teleoperation. So here we are not only intent to enhance productivity and precision, but also to support workers to work safely and improve radically their well-being by removing them from the dangerous environment. Another example, the final pilot of JARVIS goes to the offshore energy production. We're working with Equinor here. The current state involves complex and harsh environments. We have inspection and maintenance tasks as the center here. They are often performed manually in areas that are difficult to access and pose safety risks. So the vision here is to deploy mobile collaborative robots, of course enhanced by AI-based vision and interfaces to enable reactive planning and mission task planning. So the human can say, fix this valve, and the robot can understand how to navigate, go to the correct area, first of all inspect, and then if needed, proceed with intervention activities. Here we intend to enhance reliability, flexibility and safety of these critical operations. So overall, our scope is to enhance the scientific impact. We're working in 3 levels of impact. Scientific is the first one. Here we're working with robotics. You saw a lot of mobile robots, but also collaborative robotics, AI, multimodal interaction, and sensing technologies. So our research pushes forward how humans and robots can collaborate naturally and effectively. The second pillar is the economic impact. So this is demonstrated, one, with improving the operations in our end users, but also we have a series of open calls. We will fund a total of 21 pilots, and through these open calls, we aim to engage, first of all, SMEs and startups, but also developers. We aim to help them test, validate, and scale innovative solutions. And we will see more details in the next slides about this. So together with them, we want to ensure that scientific results are not just research outcomes, but together we build a pathway to industrial adoption and the overall enhancement of the European competitiveness. The third pillar is the social impact. Of course, in a project where we have human-robot collaboration, the main scope is to enhance well-being. We want to reduce human exposure to hazardous environments. This is mainly demonstrated with the nuclear and offshore sectors. We want to improve ergonomics and at the same time fine-tune trust of operators to AI and robotics. We don't want them to trust more than necessary, but we want them to trust as much as needed to work efficiently. So now the open calls. We have 2 open calls. The first one is now closed and the second one will be in the next year. The concept is that we have 2 types of applicants. One is under the co-development open calls. Here we have developers, integrators, and we want them to support us comprehensively enhance the operation of our use cases. And then there's the external pilot open calls, where the JARVIS tools will complement solutions of external pilots. So here we have consortia. They include both the solutions developer, but also the organization providing the use case. And the overall goal of this framework is to stimulate the engagement of SMEs in testing and validating their solutions and the JARVIS solutions, to extend the adoption of the developed tools, both within JARVIS, but also external to JARVIS, and to support the development of JARVIS solutions through provision of feedback and lessons learned. So the external pilots will support us with providing feedback on what we need to improve in the reusable toolsets. You can see the 2 types now in a more structured view. I would like now to discuss some first results. So from the first open call, which closed in May, we selected 8 external pilots, which span in different sectors, and we're very happy about this. We have shipbuilding, textiles, e-waste and circular economy, remanufacturing, energy, chemical industry, plastics manufacturing, and healthcare. So there is a huge opportunity to demonstrate that the JARVIS tools can be applied in very different contexts. And with this, I would like to conclude the JARVIS presentation. Thanks a lot. We hope to interact with you in our social. You see here our website, and we will be happy to hear your feedback about the project.
Thank you very much, Zoe. Excellent presentation. So I think we have one question. So you indicated that JARVIS follows an industrial-driven methodology. So how do you envision the sustainability of the project? This is the first question. So I will do the second one later, so you can answer.
This is a very nice question. So within the project, we started with requirements from our end users, and we hope that our solutions will be kept in their production. So at the end of the project, we will go at the facilities of the end users. We will deploy our solutions as a system, so in pilots in their lines. This will reach TRL 7. So we hope that they will be interested to continue in the next TRLs until they deploy the solutions. At the same time, we have technology providers like KUKA and Net Company, who will enrich their product catalogs. So our solutions will be adopted and further extended in their portfolio. And then the final sustainability in terms of economic, I understand they want to know how our solutions will continue in the next steps. We have the SMEs, which we hope to support commercialize their solutions through the open calls. As for the research organizations, of course, we will take the lessons learned and continue with next projects, policies, upskilling courses and webinars. So it's several levels where our solutions can produce results.
Perfect. Excellent answer. So the second question is the purpose to monetize on the modules building blocks of JARVIS and boost company solutions? So do you plan to monetize the outcomes of JARVIS project?
So I guess this has a lot of stakeholders. Some organizations are for profit, some are not. So the ones that are for profit, of course, they are involved in this project, they see it as investment and they want to monetize. Again, it's the technology providers that can monetize the solution. They sell either services or products, and they will directly monetize. Operations will be improved, and this will bring back some cost reductions. And yeah, the SMEs that will develop solutions within the open calls or actually enhance their solutions, because we ask for TRL 7 deliverables. This is what is expected at the end of the open calls of external pilots. I guess it will be easier for them to commercialize their solutions and sell after JARVIS. We start with TRL 5, and through the 10-month program, we ask them to advance to TRL 7. So it's mature solutions. They will be demonstrated at realistic environments. So we also help with the business perspective by advising them. So we want to see commercialization.
Thank you very much, Zoe. So thank you for the presentation. So let's continue now with Mireia de Diego. Mireia Moro is a telecommunication engineer with a master's degree in industrial electronics and automation. She is specialized in automation, robotics, and also industrial process control. She has experience in managing and coordinating national and international projects, mainly focused on industrial digitalization. And currently, she is the coordinator of ARISE project that's aimed to develop collaborative robotic applications within the framework of Industry 5.0. They are also working on the implementation of interoperability technologies for production process optimization and digital transformation, and also is involved in research projects on applied artificial intelligence.
Our project, ARISE, is a sister project together with FORTIS and JARVIS. And next slide, but with this continue with the overview of the project. The main pillars of the ARISE project is the two concepts is different. The most important is the open source technologies, tools, and utilities for agile, cost-effective, and sustainable innovation in this human-robot collaboration. Is a different open technologies that our partner, our tech provider, as a partner in ARISE, provide the different releases along of the project. And the other pillar is demonstrating in this industrial added value as the human-centric aspect. As you can see in the logo, you have two important parts, the purple and the orange, is the collaborative of this part. The objectives in the project is these challenges of the complex tasks in the manufacturing and services and healthcare in different sectors, and to use the ethical principle, inclusiveness, and safety and industrial in different workplaces. But we have open call, we have real-time scenarios for to implement this human-centric and this SSH framework. And the impact is in this part, the human-centric at the center, in the all of the application, in this collaborative robotic application, is in this concept, the Industry 5.0 principle, is we move to this Industry 5.0 with this type of the projects in this innovation solution. Next slide. This is our consortium. We are the coordinator. CATIF is a technology center in Spain, in Valladolid, and the tech coordinator is Fiber Foundation. Fiber is a European standard that we use in the application, mainly in this collaboration with the other external third parties tools in the factories. And the consortium is mainly this tech provider and the owner of the 4 pilots, and the funding boss is leader of the management of our open call, and the Mos Helsinki is our expert in this SSH framework. And the community is different events and congress and this type of event. And the community that we are, the Fiber iHub, our pilot, we have a pilot that is involved in this community. We have a cluster for manufacturing. Along of the project, we want to create a great collaborative robotic ecosystem. Next, Daniela, thank you. This is the ARISE roadmap. Mainly the first year of the we start in 2024. We have more 1 year and a half right now, and the experimentation in the pilots is in this first year. Now we have the other development with the new releases provided by the technology providers. And these pilots emerge new challenges, not the original new challenge that we need to address in the proposal time and the grant agreement at the first of the project. Emerged new challenges, and this collaboration with the experiments in the open call. Right now we are working with this experiment in the first open call. We have 3 months working with them, and this funded experiment, and we are in the proof of concept. They are working in the minimal viable product. In the next deliverable, we can see the development in the pilots, and we have a different evaluation stage. And the idea is when the outcome of the first open call and the second open call, we have 2 rounds. We have this collaboration with the demonstrators and the different modules, human-robot interaction modules that will be this outcome of the processes. And we have this feedback and this ARISE toolbox created with the demonstrator, the modules created in the demonstrator and the outcome of the open calls. And we have this roadmap and iterative innovation process. And the community, this community and the open source technologies and the other communities in the European Commission. Always we have maintained the SSH framework in all of the pilots, and this support SSH support in the open call for the by this Demos Helsinki as the leader of this part. Next slide. The pillars in ARISE is mainly the open source technologies. This standard facilitated the creation of this middleware that we named this ARISE middleware. It's composed the different open source technologies and the human-centric automation design. That's this SSH framework and the AI power models with reusable skill. We have multimodal components, but in the different pilots using the different AI models and different standards, and create this interaction will facilitate the collaboration human and robots. And the 4 testing and experimentation facilities, we have 4 partners that are owner of the different facilities. Captive, in our case, as the coordinator, we have the coordinator of all of the facilities. And 26 funded innovation project in 2 rounds. We are working with the winner of the first round. We launched the second open call in October next year. Next, Daniela, please. This is our middleware. No, this is our open source solution. Fireware, ROS2, Vulkanexus, and ROS4HRI is different open source technology. We have this expert in our on board in our project, but to facilitate the integration in the pilots. Next, Daniela. What is the middleware? That this middleware will address in our pilots with this experiment. 3 elements are the principal, and the first is the reusable application. The idea is that we are developing in our pilots in the experiment. The idea is to facilitate that the others that the other external and in our community, this model will can be useful for this community, and to have for different application, different tools, that you have models that is not everybody have to start again and again, but have the different starting modules, but to facilitate the creation of the more and more collaborative robotic application. And the other is this connecting with the system and robots, is the facilitate this middleware, this will facilitate the using the different open source technologies in this community. ROS2, Vulkanexus, ROS4HRI, that the different technologies facilitate different parts and to integrate different application in devices. And the other part is this open source, the fiber, this standard, that's integration with this assistant system, that not to replace the different system, that this communication will be easy in the industrial environment. That at the beginning, fiber years ago is more common in the smart cities, but now they are working on these industrial scenarios. And next slide. The concept of the use to be easy to use this concept, that you using this middleware, this ARISE middleware is a modular to facilitate or to promote the modular design and the interoperability in the different third parties and different systems, reusable application modules, and scalability and adaptability in future growth in the future in this community. This is our you can see in this figure the different parts that you can see in the industrial scenarios, the operational plane, that the robots, different machines, different connection with the databases, and the collaborative robotic applications. That is this part is that you use in the pilots, and the connection with the artificial intelligence model, simulation, different API protocol, different systems, RB, MES, and so on. Next slide. And this is the map in the project. The devs are at the center in the project, and the middleware, we have the middleware provide the different releases, but the pilots provide that the middleware expert for these requirements and the matter and issues that the pilots can find in the testing, in the training. And the TEF, we have a concept with the TEF that the living labs, we have issues, and we need to address different, to solve different problems. And the ethic and SSH framework, we have interviews with this expert, but in the about robotic application, different conversation, but they provide the different aspects and the different knowledge that we don't have in this aspect. And the support and mentoring, we have a connection with the pilots, but it's a connection with the experiment and the owner of this experiment, and they provide the guidance, documentation, handbooks, but the experiment have other easy way to facilitate these outcomes. And the FSTP calls, that this connection with the provide, for instance, technical islands and doubts about the integration in the future in this experiment. And the idea is to have a living lab, a completely living lab, a demonstrator with this, all of this technology, and the human-robotic interaction model that emerged this along of the project in these different milestones and deliverables and parts. Next slide. The idea, what challenges are you facing? All of the experiment and the development in the pilots, we have a three-pillar, an important three-pillar: human-centric design. This human is in the center, not in the years ago that the automation is the most important. The robots, the configuration of the robots and the programming of the robots is the most important. The human is in the center. The empower that not to replace, not replace the human for the robots or the automation control, not to empower this role, the human roles, avoiding the replace in the different parts. And responsible and ethical, ensuring emerged solutions and responsible with this SSH framework in the center. Next slide. And the challenges that we have for pilots, with we need to address different challenges and the different 2 challenges per pilot. For instance, in TEF1, we have dismantling and assembly high-value products and complex product picking. And IntelliMeds is our partner that is an owner of the other pilots. We are working in flexible collaborative robotic, assembly and packing, and smart programming robotic kitting assistant. PAL Robotics is other owner, is in other sector, in the healthcare sector. We have different multimodal human-robot interaction with different mobile robots, and FET and Caritas in the healthcare environment in hospital and healthcare centers. Another pilots, Polimi, Politecnico di Milano is the center, is the owner of the pilot, and we have they are working more in efficient and precision tasks and the ergonomic aspect. And so, next slide. Is unfortunately we can't see the videos, but it's a challenge. That's an example that we are working in Cartier, dismantling and assembling hollow product. We're using different technologies, mixed reality integration, robust both command recognition with different intermodal models that using natural voice with this interaction with the robot, and maintain the data protection and privacy principle and ethical handling and human data. The idea is using the HoloLens, this mixed reality with these glasses, and assisting the robot in the scribe driving. Next slide is an example. We have this first open call. We have a success in the rejection of the application. We have more 100 application in this part for the winner. We have available 13 experiment, only 13 experiment, but we have a good selection of the idea in this part was selecting the high proposal, not all of the challenges that we have available for 8 challenges. The idea we have a doubt that is most important to address all of the challenges or the high quality of the proposal. Finally, we decide that the high the high value of the proposal is most important, but not all of the challenges in this open call we are addressing. But in the next open call, we will need to balance all of the challenges. But in all of the projects, we have all of the challenges that for these external beneficiaries. And different 22 SMEs is on board in this fair open call. Next slide. This is the different experiment, the different names of the experiment. We have they are working in the precision task, in multimodal human-robot interaction, in dismantling and assembly, in different parts. We started 3 months ago, and I think it's a good experience. It's a challenge. It's a challenge to have a lot of experiment working in different developments and to give a support in the different aspects in the SSH framework, in the middleware integration, and the business support in the communication and the creation of the community. Next slide is other projects, is the total of the projects. Next slide. We have this opportunity, the second open call. We are launching in October. In 1 month, we launched in our microsite this opportunity for other 13 beneficiaries. Support for project is 200,000 euros, and the idea is to have the SMEs and the consortia. The possibility is to have single SMEs that play the 2 roles: the technology provider and user, and the consortia composed for 2 partners, technology provider and end user. We have an opportunity. It's possible that the consortia we have a 3 partner that is an additional provider. We are analyzing this part. It's possible that this QR code is not available right now, but it's possible the first open call, but this will be available shortly. Next slide. The idea for the impact of the ARISE project in Europe, in this community, in this community, in this European community, the idea is to promote the open source technologies. Our middleware is that the developers facilitate for the developers the use of the different standards and gaining the interoperability in the different industrial sector, not only in that we are addressing the manufacturing and healthcare and different logistics and services, that this model can be used in the different domains, in the different environments, that it will be available, and other projects or other partners can be used in this community. And the ecosystem building with our pilots and the FSTP beneficiaries. And the idea is to create community with the Digital Innovation Hub, FiberEye Hub, and we are creating test manufacturing cluster with the different external, not the beneficiaries, the Tampere University and Fiber Numérique in France. And we have involved a different partner in this cluster for manufacturing, in this idea that to create a virtual test and living labs, that in this idea that virtual test can be useful for external in the future. And long-term goals in this sector that we are addressing, and the other improve the productivity, the cost reduction to facilitate the creation of the with this middleware and ethics and safety. Then the pillar of the SSH framework is important in our project, and the main goal or the final goal is to improve the European competitiveness in the world. Next slide. So is the final. Let me know that you have doubts or questions about our project, interest in the open call, let me know via our social media or our email, and we are a pleasure to receive this type of the collaboration. Thank you.
Thank you very much, Mireia. So we have some questions. I am going only to ask one. How does ARISE define successful interaction between humans and robots?
Affects in this collaboration in the human and robot in the pilots to facilitate the collaboration. We are using all of our technology available tools that this, for instance, the artificial intelligence at the beginning of the project, when the time in the proposal time is not to develop all of the applications on this collaboration with the models, but right now to facilitate, for instance, this multimodal interaction, and this facilitate the SSH framework. SSH framework to facilitate that no problem in this collaboration in human and robots will be easy in the future, or more natural, with this natural common voice, and more productive innovation, but the safety in principle.
Thank you very much, Mireia. Thank you for the presentation. So I think we are a bit late with the agenda, so I would like now to proceed with the roundtable. I think, I don't know if there is any question from the audience that you would like to comment for Zoe, Mireia, or myself, but if not, I can start with one question and then wait if some of the audience have some specific questions. So, okay, so in your opinion, what is a major trend you are currently seeing in human-robot interaction research that you believe will have a lasting impact? So which is the trend, human-robot interaction, you think it will come to stay with us in the industrial domain? So I don't know who wants to start, Mireia, Zoe? You want to start, Mireia?
I can start.
Right.
You asked about the main trend, no? The main trend.
Yes.
I think we have the idea is this. For instance, in our case, is these open source technologies or this artificial intelligence model can facilitate the collaboration in different environments. But right now, we detect in the human-robot interaction that the different domains or different environments are separated. That is, I think, is, for instance, construction is not is really different than the healthcare. But I think it's possible in our, for instance, that I commented that the creation of the cluster for manufacturing. The idea is to incorporate a different domains or sector, not manufacturing, but or in industrial, but it have a different aspect that, for instance, our expert, Demos Helsinki, as the expert in this SSG framework, need a lot of inputs of different sectors. It's necessary that this raw material, for that they can analyze the different aspects that involved in this part, but to facilitate the collaboration of the different sectors in the future, I think is possible that to work in the 5.0 industry that is more collaborative, more narrow human robotics interaction will be narrowed in the future. Yeah.
Thank you very much, Mireia. Zoe, do you have some thoughts about it?
From our side, what we see that people want, the end users, but also what we see that people develop is actually focusing on easy programming still. Like what they need more is interfaces, first of all, to start the commissioning of a new process, but also to make micro adjustments, like when something doesn't work for some reason, or when we have like high mix low volume production and we need like to make small changes, they want that the operator ad hoc makes these adjustments. I guess this is also because programming can be a bit separated from the production system, so we can say that it's the first step into advanced technologies, so they can test like how this is working. It's not critical for the production, it's something where they can take a small risk. Investment is not very high, so yeah, in general this robot programming aspect is a hot topic, we can say.
Yeah, thank you very much. So yeah, I agree with your description. This is mainly the new approach about human in the loop. I mean, the artificial intelligence embedded in the robotics is the one providing intelligence, but sometimes they need adjustments. So the human has to intervene just to improve what the robot has learned. So I totally agree. And I think the trend in human-robot interaction, we are seeing and I agree with Mireia, we need to advance in the part of industry, but where I see the domain where I see that we are advancing more is in the healthcare, using the robots as companions to the people. So I think we are still seeing the robots as a companion, as another person who help people, and not as a worker who work with us or collaborate with us in the industrial domain. So I think we need to continue working on seeing the robots as not as a machine, as a new entity, as a companion that helps us to perform different activities, not only in the industry, but also in healthcare and in other domains. So I think that would be the trend we need to see, and that's why we are involving the human more in the loop and trying to see how the human behaves, so the robot can adapt the interaction to that behavior, to that state the human is in this moment. So we feel that they are more human-like and not just a robot part. Okay, so I think we are going to have a second question because we have a question from the audience. So a participant works at a company who works on human-robot interaction, artificial intelligence, and robotics. But currently, they are mostly more focused on education and welcome robots. They have worked on industry use cases in the past. So the participant asks, what would be a good path to bring those skills to industrial use case? So yeah, this is aligned with what I have mentioned now. So yeah, I think the education and welcome robots are more licensed. A person focused on more focused on interacting with people. We don't expect that they perform a lot of complex activities, but I think this is some trend we need to apply to industrial robots, just to evolve from machines to companions. So I think those skills could be very, very interesting for industrial use cases, to understand the human, to know how the human is going to behave, to predict the human intent, and to adapt the behavior and interaction of the industrial robots to that human. So that's my perspective. I don't know, Zoe, Mireia, do you
Yeah.
have some thoughts on this?
I totally agree. And I will improve this communication with the robots. The idea, I think, is improve this interaction to facilitate the multimodal interaction of the via natural voice or different behaviors that this robot can't detect. I think it's necessary a lot of data and the training of the system with a lot of data, the different human behavior data or different this knowledge at the system. I think it's possible to have improve this behavior human robot in this collaboration. I think it's the idea. I think it's the data in the future, the big data and the artificial intelligence technologies and algorithms, and will improve in the future. I think it's in this way.
Thank you very much, Mireia. Zoe?
And complementary to your comments, it's worth also investing on the human. So we need to make sure that there is enough upskilling provided to the operators. So it needs training for every new technology that will be deployed in different contexts, covering also industry. We need training. So although technology providers try to make it intuitive, we also need to make sure that operators know what to expect from technology and how they can cooperate, since we have this demographics situation where we have the aging workforce, where they have a lot of experience, but they don't know what to expect from digital tools, or we have younger people that don't know how to work on the domain. So we need, first of all, to make sure that there is knowledge sharing between these people and all of them know how to work in teams together with the robots. So we should also check what humans need to adopt the solution. So design should take into account humans.
Thank you very much, Zoe. So I think with this, we can close the roundtable. So I would like to thank you, Mireia, Zoe, for your presentations and sharing your thoughts about the evolution and the future of human-robot interaction. And now I would like to give the floor to the host, Daniela, so we can conclude the webinar.
Thank you so much, dear Leila, for your, first of all, for your facilitation, your fantastic facilitation for today's discussion. And a huge thank you for all your sharing your valuable insights and expertise. It's enlightening to see how each project is giving us a deeper understanding on the opportunities and challenges that lie ahead. If I may add to the question that was asked about what could be a good path to bring skills to industrial use cases. If you have the time, take a look at the open calls that are going to open for all the projects, because usually you can participate as a consortium. And if you have a more a background more oriented for education, then you can organize or make a consortium with a more industrial partner and raise the value of the things that you are working on to either test it or develop furthermore. Just a hint, dear. Just if you have the time, of course, it would be good for you also to take a look at the open calls of the 3 projects to see where do you fit. Of course, on behalf of FORTIS and all of our speakers, thank you so much for your time and joining us today. And stay tuned for the next webinar. So we wish you a wonderful rest of your day. Thank you so much and goodbye.